Hello, good day everyone. This is Tefs. Welcome back to this channel. We have a 39-inch Hisense LED TV, model 39N2174. It's not turning on, and there is no standby light indicator. I will show you exactly how to fix it. If you are interested in electronics and want to learn how to repair TVs and other electronic gadgets, you came to the right channel. So be sure to like, subscribe, and ring the notification bell so you never miss a video like this. So let's get started. My customer said the TV has no display. When he plugged it in the other day, it would not turn on anymore, and there was no standby light indicator. So let's measure the voltages. We can measure the voltage at the cathode of these rectifier diodes. No voltage is present. But we have a voltage on the primary main capacitor, which means the AC fuse is okay. Let's remove the hybrid board to conduct additional component test. As I always said, discharging the main capacitor is very important before conducting any test of any component on the primary side to avoid electric shock. Let's test the rectifier diodes for any shorts. You can use diode mode to test for shorts, and continuity mode will also work for this purpose. We should have done this task earlier, but it is clear, no shorted diode. The power MOSFET also not shorted. This capacitor is the VCC of the PWM driver. Let's measure the voltage. We have only about 5 volts fluctuating down to 3.8 volts. This is one of the reasons why that we have no secondary voltages. "325 volts is stored at the main capacitor, which this will happen when there is no voltage at the secondary section. So always discharge it to prevent electric shock or spark while conducting a component test at the primary section." VCC of the PWM driver voltage should be about 16 volts to start, but we have only 3 to 5 volts. One of the reasons that have not reached 16 volts is that it has a low resistance to the VCC rail line. So let's measure the resistance. Seems we have a very high resistance of about mega ohms at the VCC rail line. We can say that the VCC rail line has low resistance if we measure around 10 kilo ohms, which results in the voltage not reaching 16 volts. Let's test the VCC capacitor capacitance by hanging one of the terminals so we can test it accurately. The capacitance is 10.8 microfarads. The capacitance label to the capacitor is 10 microfarads. Seems the capacitor is okay. Let desolder the MOSFET with the heatsink so we can trace where the VCC gets the voltage located under the heatsink. The MOSFET is most likely to get shorts when it is damaged. It cannot be opened, it always gets short. MOSFET test is good. These series resistors are connected to the VCC line. The other end of the series resistor is connected to one of the AC lines. This is where the VCC gets its voltage. The two resistors are not the actual supply of the PWM VCC. This is for starting the PWM driver or to trigger to start. The connection is shown in this diagram. This is the PWM VCC supply came from the chopper transformer when the PWM starts. Let's test the two resistors. Seems they are good. Not at exact value, but they are close. We will not remove them to accurately test them because it's difficult to do. But I'm sure they are good. The 10 microfarad capacitor test is good, but let's replace it. Some capacitors test well, but they do not function correctly in operation. I got this capacitor from a scrap TV board. The test is good, but let's replace it to see if there is any change to the VCC voltage. The voltage is still at the average of 3 volts. Since the customer said at first it was no display, we will make sure that the panel is okay before modifying the power supply using STRW6053N. There is a method to force to start the PWM driver. We will series a resistor from the main B+ capacitor and to the VCC of the PWM driver, using 470 k ohms. I tried this method, but it doesn't always work. But let's just try it. Solder the lead of the resistor to the B+ of the main capacitor and the other lead to the VCC or the B+ of the 10 microfarad capacitor. This method is standard for some PWM power supply triggering systems. The voltage now is up to 7.5 volts, declining down to 6.3 volts. The voltage doesn't reach to 16 volts. The 470 k ohms should work, because the resistance of the VCC line is about 700 k ohms. Maybe the PWM have a leak. Let's try to lower the resistance to 120 k ohms. The voltage is now up to 19.5 volts. The voltage is higher than our target of 16 volts, but it is okay. Let's solder the MOSFET back in place and see if it will work. We have a secondary output now of 12.0 volts. We were successfully forced to start the PWM driver. This is how the connection is shown in this diagram. Let's screw back the hybrid board and see what is the next problem. We have a standby light indicator now. Turning on the TV. And no image appears. Seems the backlight is the other problem. Let's measure the LED bulb output supply. The voltage stays at the 46 level. It should go up to about 80 volts depending on how many LED bulbs are used. This capacitor is obviously bloated. Let's replace the capacitor. I didn't find a 33 microfarad 200 volts, 22 microfarad 250 volts will work. The voltage is boosting up to 78.0 volts now, and we have an image now.
One hour later.
I modified it using STRW6053N. The 120k ohms is burning. It is too low resistance to trigger the PWM driver. The PWM driver IC is defective. Forcing it to start will lead to failure quickly, so I decide to modify it. I don't include any more on how to modify it because this video will get too long if we include it. Many of you probably watched how to modify the power supply using STRW6053N on this page already.
A few moments later.
The TV now is working great. Another TV works again by modification using STRW6053N. Thank you for watching. I hope you enjoyed and learned something from this video. To help this channel grow, please like, share, and subscribe. Remember to click the notification bell to stay updated on new release videos. Once again, this is Tefts. See you again next time. Bye for now.